Fight!
Greetings, everyone. Today, we're going to discuss the topic called inverse variation.
So before we proceed, what is inverse variation?
Inverse variation. It is a relationship between two variables in which the product is a constant. It is exactly the opposite of direct variation. As one number increases, the other decreases. This is also called inverse proportion. An example would be the relationship between time spent goofing off in class and your grade in the midterm. The more you goof off, the lower your score will be.
Example for that is when you travel to a particular location, as your speed increases, the time it takes to arrive at that location decreases. And when your speed decreases, the time it takes to arrive at that location increases. So, the quantities are inversely proportional.
While direct variation describes a linear relationship between two variables, inverse variation describes another kind of relationship. For two quantities with inverse variation, as it was said earlier by Cassiopeia, one quantity increases, the other quantity decreases.
So basically, in inverse variation, as the x go up, the y's go down. Remember that the direct variation is one when k is positive. As the x go up, the y's also go up correspondingly. But here with inverse variation, what we see as the x go up, the y's go down, and inversely, the x go down and the y's will go up. That's why they're called inverse.
We say that y varies inversely with x if y is expressed as the product of some constant number k and reciprocal of x.
However, we must remember the value of k can't equal 0. Isolating k on one side, it becomes clear that k is the fixed product of x and y. That means multiplying x and y always yields a constant output of k. The statement y varies inversely as x means that when x increases, y decreases by the same factor. In other words, the expression xy is constant, where k is the constant of variation. We can also express the relationship between x and y as y equals to k over x, where k is also the constant of variation. Since k is constant, we can find k given any point by multiplying the x-coordinate by the y-coordinate. For example, if y varies inversely as x, and x is equals to 5, and y is equals to 2, then the constant of variation is k. So our solution for that is xy is equals to 5 multiplied by 2, because we're going to substitute x to 5 and y to 2. And the answer for that will be 10. Thus, the equation describing this inverse variation is xy equals to 10 or y is equals to 10 over x.
So, in the given table, let us tell whether y varies inversely with x. In the table below, in the table x has 2, 4, 6, 8, while y has 12, 6, 4, 3. In order for the table to have an inverse valuation characteristic, the product for all pairs of x and y is the data set must be the same. As you can see, the product of our x and y are equal to the same key value. Since 12 times 2 equals to 24, 4 times 6 as well and vice versa. 8 times 3 to is equal to 24. So they are all equivalent to 24. The product of variables x and y is constant for all pairs of data. Now we can claim that k equals 24 is the constant of valuation. So the equation for this one is y equals k over x, and since k is equals to 24, well, replace k to 24 and there's our answers.
Now, let me show you how to graph the equation y equals 24 over x with the points from the table. So first, we need to plot. Let's base from the given table of values. First in line, we have 2 and 12. Next, we have 4 and 6. And we have 6 and 4. And lastly, we have 8 and 3. Since we're done with the plotting, now we need to connect these dots. And there you have it, our graphing the equation of y equals 24 over x.
For our second example, if y varies inversely as x and y equals 6 when x equals 4 over 3. So at this juncture, we'll write an equation describing the inverse variation in the table. X has 0.25, 0.50, and 0.75, while y has negative 12, negative 6, and negative 4. If the data in the table represents inverse variation, the product of x and y must be a constant number, since 0.25 times negative 12 is equal to negative 3, 0.50 times negative 6, as well as 0.75 times negative 4 is equal to negative 3, so they are all equivalent to negative 3. Obviously, multiplying x and y together yields a fixed number. This becomes our constant of variation. Thus, k equals negative 3, so the equation for this one is y equals k over x, and since k is equal to negative 3, we'll replace k to negative 3, and there you have it.
For this problem, we'll base our plotting in the table of values like we did before. So we have 0.25 and negative 12. Next, we have 0.50 and negative 6. And lastly, we have 0.75 and negative 4. 0.75 and negative. There we have it. Now, we just need to connect these dots. And there you go. We have our graphing of the equation y equals negative 3 over x.
The length of a violin string varies inversely as the frequency of its vibrations. A violin string 14 inches long vibrates as the frequency of 450 cycles per second. Find the frequency of a 12-inch violin string.
Earlier, Alain stated the problem, and now I am going to show you how to solve the problem. The length, or L, varies inversely as the frequency, or F. When the length increases, the frequency decreases. When the length decreases, the frequency increases. Now, we will write the formula of inverse variation. The formula of inverse variation is x times y is equal to k. So, since our given is length and frequency, we're going to change x to L and y to F. So, our formula is LF equal K. Substitute 450 to F and 14 to L. Since the L is the length and the length is 14 and F is the frequency and the frequency is 450, we are going to substitute L to 14 and F to 450 and find the constant. So 450 times 14 is equal to 6,300. So our K is 6,300. We have to find the frequency of 12 inches violin string. So 12 times F is equal to 6,300. And then we need to solve the F. So F is equal to 6,300 over 12 and divide the 2. So the answer will be 525. Therefore, 12 inches violin string vibrates at frequency of 525 cycles per second.
The volume of a gas varies inversely as the pressure on it. If the volume is 240 cm cube under pressure of 30 kg or centimeter squared, what pressure has to be applied to have a volume of 160 cm cube?
Now, for the second problem, I will also show you how to solve this problem. This problem is quite similar to the first one, so don't get too confused. The volume V varies inversely as the pressure P, means when the volume increases, the pressure decreases. When the volume decreases, the pressure increases. Now, we will write the formula of inverse variation. Just like earlier, the formula is X times Y equal K. Since our given is volume and pressure, we were going to change P, X to P, and Y to V. So, our formula is PV equal K. Now, substitute 250 for P and 30 for P. In the formula and find the constant. So, 240 times 30 is equal to 7,200. So, RK is 7,200. Then, we have to find the pressure when the volume is 160 centimeter cube. So, 160 times P is equal to 7,200. So, we need to solve P. So, P is equal to 7,200 over 60. And we need to divide the two, and the answer will be P equal to 45. So, therefore, pressure 45 kg per centimeter squared be applied to have a volume of 160 centimeter cube.